So first of all, thank you everyone for coming and attending my session. So this session is about how to make things that are, let's say, compatible with your life cycle. They're gonna, let's say, be fit into your continuous delivery pipeline, but it's not gonna forbid your developers to go fast and your compliance guy to make sure that the things are done properly. And we are not going to show it in theory. We're going to show it in a real case scenario. So this demo that I prepared for you today is not a fake demo. This is a small scale or a real use case we did for some large clients in Europe. And this has been already done in London with a much faster connection. And here I'm trying to make it work by connecting via my mobile phone. And as you know, the mobile phone network in the US is not great. So if something breaks, it's not my fault. Yeah, yeah, but just is so slow. Okay, so just about GerritForge, that is a company I work for, and I founded about 6 years ago. So it's been founded in 2009 in London, and our main focus is contribute to open source. And we started with Gerrit, but then we extended our scope to Jenkins, to Kibana, and more recently we started contributing to a lot of open source big data projects, such as Scalding and Avro. Just a question, because I would like to make the session more tailored to you as much as possible. How many of you guys are working in big data? Can you raise your hand? Okay, that's really good. In London, it was just me and another guy on the room. So I say, guys, there's something wrong. Maybe you chose the wrong session. No, you are on the right session. Okay, so about me. So I'm Luca Milanesio, as you can see from the name, and not so much my accent because my voice is gone. I'm Italian, but I moved to London and I've been working for over 20 years in application lifecycle. And the other team on the slides are the team that presented together with me, and they are part of GerritForge. They presented in London, but they were just on holiday now. So I say, why don't you spend your holiday in Santa Clara? And they say, actually plan my holiday for Peru. So they are somewhere else in the world, but they contributed to this demo as well. Okay, so first of all, the first question we're gonna ask today is, why on earth we need continuous delivery for a big data project? So because the way that big data started was really not really similar to a typical continuous development lifecycle, was a little bit different. We are going to see how it was different and why even in big data we need continuous delivery. Second, we are going to see exactly all the tools that in our case we use for our continuous delivery pipeline. And it will be really nice to see and to hear from you what the tools you are using and what problems you are facing. Yeah? And we are going to see then, in our case, how we managed to resolve some of the peculiar big data problems in a continuous development environment and continuous delivery pipeline. And there will be the demo if the network assists me in the demo itself. So look, yeah, we have three lines over 5, so far the network is fine. Okay, so let's start from the first point. Why? So we've been working for the past 2 years for very large clients in Europe for big data projects. And we've seen that the way they were organizing their life cycle was quite crazy. But they were explaining to us all the time, yeah, it's crazy because big data is different. So they were saying, yeah, in big data, you don't really have security. Everyone can do whatever they want because in reality, you always work in these interactive modes. Even with the new tools such as Apache Spark, you basically use most of the time the shells. And then lots of people do use a notebook-style development style. That is, you don't write code anymore. You just got a kind of notebook that allows you to write code and get the result in real time. So that was one of the reasons why they were saying we don't need even continuous integration. Why do we need continuous integration? We just do the stuff and it's already live. But in reality, that was just the beginning of the phase of the project. So the big data project had many phases. The first part was the discovery phase, where you don't really have any clue what the information they need to get out of the data. They got this giant set of data. Our set of data was about 15 petabytes. It was for a large media company in, it's not just Europe, it's kind of a global company. and they were getting just information coming from all the viewings of all different people having their set-top boxes. They were getting, for sure, lots of data. But the first phase was the discovery. They didn't know what they want to get out of the data, so they had those data scientists that were using the notebook style just to understand how to extract features from the data and putting them together. But then, this type of discovery phase needed to go to a more traditional production phase. So they needed to translate those notebooks in proper code, and they needed as well to make this proper code to be production ready, because then this type of metrics they were extracting, they were key for a lot of data. For a lot of information was mission critical for the business. For instance, the audience on the viewings on the programs determines how much money you get out of the programs. And you can't afford anymore by saying, yeah, that was my notebook, but I changed it later, and maybe I introduced a regression on my indicator, and we had just lost 1 million yesterday because we just changed by mistake the metrics and the way we get revenues out of the viewings. And that is not acceptable. It could be acceptable for the discovery phase, but when you go to production and you start using the features for real business and generates real money, you need to make sure that it's done properly. So first of all, we started looking at the tools we were using. So we were using Scaldi. How many of you have used Scaldi or have heard of Scaldi? Okay, one person out there. Do you use Scaldi unit?
Yes.
We built the Scaldi unit, yeah? So Scaldi unit did not exist. And we said, listen, there is something wrong in Scaldi. It's really nice. There is the ability to do some joint testing, but how can you do test-driven development with Scaldi? And then we built it because it didn't exist, and then became part of Scaldi because the guys from Twitter that are the author of Scaldi, and they decided maybe this is a good thing that we should have in the framework. Then we look at Jenkins by saying the client was using Jenkins, but for a completely different reason. We say, why don't we start leveraging Jenkins itself in order to give it more structure to our development tool, development lifecycle. And we started for integration performance testing, not just for unit testing. And then, of course, there was one piece that was missing. So a lot of validation was done just by sitting together with the data scientist. Again, that is really good for the discovery phase. But when you need to make changes to production code, to make sure that the changes you are doing are getting validated to all the parts of the business, because they are going to influence as well how much money you do, maybe you need some proper code review. Okay, so that was the challenge. But the business said, listen, we don't want to slow down. So with the notebooks, we were really quick. We want to make sure that we do things properly, but going exactly the same speed as we were going before. So that was the challenge. It's not easy, right? Because from one side, you do stuff, just click play, you see the result. From another, you write code, this code needs to be built, the build takes time, you get the feedback, the people need to get the feedback, and then maybe change again the code 10 times. So how we managed to, let's say, tackle this challenge? So first of all, we said we need to use some development practices that are allowing us to deliver to production at any time, because the business wanted the same type of agility that I had before. They wanted a change, and the change was live. So even with the continuous integration, we needed to achieve the same result. So we needed not just to the integration, but we needed to automate a delivery pipeline. And in order to make sure that the delivery pipeline is always stable, we needed to make sure that every commit we were making to the code was always stable. The second part, we wanted to make sure that whenever we were building a patch set, this patch set was going to be deployed to all the system automatically. So not just validated, but actually going live. So in a way that the business could have seen in pre-production, whenever they were asking for a change, what was the impact. So the workflow we implemented is the typical code review workflow. So how many of you have done any code review before? It's good. So for all the people that raise their hands, are you familiar with this workflow? Raise your hand if you're familiar. Okay, not so many. So let's go through the workflow once again. So the workflow explains how is the life cycle of a change before going to its target branch. Imagine that I've got a data scientist that has a fantastic idea to change the way that calculate a specific feature, extract a specific feature from the data. So they come to me, they sit together with me by saying, Luca, why don't we make this change? I say, why not? Done it, committed. So you do the change and you push your change. But instead of pushing directly to your target branch, as you don't know upfront if your change is good or not, you're pushing into a state that is called review. And we're going to see in practice how it works. When we do this push, we've got some automatic process that happens behind the scenes. The first process is the number 3, that is build and test. So we'll have a Jenkins continuous integration environment configured to fetch our code, start integrating with unit tests, with integration tests, and do a lot of stuff we're going to see in practice. And at the same time, you've got as well maybe other data scientists, the other people in the business, they are looking at your changes and look at if from a global perspective makes sense or not. At the end of the day, the two branches, they come together to scoring. And the scoring is just a moment in time where you get all your feedback you've got of your change. That is maybe some positive feedback by saying, yeah, your change makes sense. And some negative feedback, they say as well, yeah, your change makes sense, but you've broken many other features. So maybe it makes sense, but needs to be refined a little bit. And if the scoring is positive, your change is going to be pushed to the branch. And if it's negative, you're just going to provide a feedback to the developer by saying you need to make it better. Okay, is there any question on this workflow? For sure, plenty. Yeah, go for it.
What do you do with the artifacts generated at this step? They go into the template environment for testing?
So can you repeat?
So you mentioned that you build a team which is not part of this master master.
Yep. Okay, so my understanding is that your question is, okay, you're pushing for review, but what about if your changes are not good enough? What do? You throw them away, you keep it in a branch, and so on. Okay, in reality, when you push your changes, you get to the score. The changes are potentially available to any environment, right? It can potentially be used by anyone. You just decide that they're not going to be in the branch. But they can be seen. They can be fetched by the people. They can be tested. They can be, let's say, used for whatever purpose. And we're going to see that in practice, so it will become more clear. Okay, the second thing that is peculiar for big data, but can be applied to many other projects, is the fact that we needed to make sure that different changes were reviewed, but different changes could be put together to a group of things that needs to go together. So just to give you some example, I can do a first change that extract a feature from a set of data. But then from this feature, I need maybe to change the way that I calculate a key performance indicator. And maybe based on that, I need to change as well the way I do reporting. So you see that there are 3 different changes potentially that needs to be isolated because there are 3 different things. And when you do change in a project, it's very important to isolate different things in different commits. But at the same time, I wanted to be sure that when they go together, they stay together. I don't want to risk to go and trigger a build if one is done and the other is not. Yeah? How many times happens to you that maybe people are pushing changes in a module, they don't push in the other module, and the build breaks in the integration test just because not all the changes have been committed? Raise your hand. This is quite typical in Git, because before Git, the people that were used to push into a big giant repo, so with a big giant repo, you don't have this problem. There is just one blob that is called the company. So when big giant repo is called google.git, yeah? Whatever you do in any project in Google, you push to google.git, of course you don't have this problem. But maybe the repo becomes too big. You can't work in parallel. But when you start splitting things, you need to make sure that things are sticking together. And that's why we decided to use Gerrit, just because Gerrit is the only tool in the market and happens to be even free that is the most powerful that can implement this type of feature that is called topic aggregation of different commits. So for the ones that are not familiar with Gerrit, so this is the Gerrit mascot that is called Diffie. It's just a small bird that stays in on your shoulder. There is a physical copy as well, but the guys from Google didn't manage to come over to give you the physical Diffie that stay on your shoulder. And it's basically not changing the way you work, just giving you advice what is good and what is not. The second tool, you know for sure, so I will not spend time saying what is Jenkins, otherwise you are on the wrong conference. And the third part is CDH. So there were some guys from Cloudera visiting my stand just before. And CDH is, I would say, the de facto standard when you work in big data. How many of you are using CDH? CDH is Cloudera. Okay, the others, they're using big data, they don't use CDH. What do you use? What big data platform do you use? The other people that were raising their hands, they don't use Cloudera? Mapr. Okay, Mapr is another one. It's not open source, but it is one very popular one. In our case, we did with CDH, but can be easily done with others as well. And the problem is when you start using big data, the ability to isolate your changes into a self-contained environment are really thin. And you really need to be sure that when you do integration tests, you integrate with the real thing, that is the real big data platform. And it's not really simple to contain this. So what we did is to just ask something into the open source community to help us out. And what we used in our experience, but maybe you guys have got different experience, so we started using some meta virtualization system. One is called Docker, that many of you already know possibly. How many of you are using a Dockerized infrastructure for big data? Raise your hands. Good, that's really good. The others, do you use a physical infrastructure or virtualize with something else, VMware or? Yeah, what do you use? VMware, for instance. So the difference between a Docker and VMware, for instance, was that Docker allows us to virtualize just the application. So creating and destroying a virtual machine in Docker takes seconds, if not even less than seconds. Why, if we go with VMware or something else, will cost much more. And we use two tools for managing those Docker images. The first one is Mesos. Mesos is basically an open source tool that allows to virtualize the amount of physical resources you've got and cut them in the way you want. It automatically manages a lot of CPU, memory, storage, and whatever resources you've got. And this was really good, first of all, because it was open source, so we were not charging our client for anything extra. They were not needed. And secondly, allowed us as well, not just to manage the CDH machines, but even the other machines. So we needed a Gerrit instance, we needed a Jenkins instance. We say, why don't we put everything on Docker? Not just big data, but everything, in a way that if the client wants to run into a different infrastructure, they can do it in seconds. And the second one that we use is called Marathon. Marathon is another open source tool on top of Docker that allows to expose the ability to deploy an undeployed application on the fly using a very simple REST API. Just to give you, just to graphically visualize exactly their console, how they look like. For instance, in terms of our application, those were our three applications. At the moment, we got just Gerrit, Jenkins, and the registry itself, because we implemented a Docker registry. Well, all the machines were archived. And for all of them, you got how much memory they need, how much memory they're using, how many CPUs, and so on, and the running as well. So why the virtualization was important? Because when I do the continuous delivery and I want to test all the applications in isolation, I need to have a dedicated big data instance created on the fly. If I don't virtualize, that will take so much time that the continuous delivery pipeline will last forever. Okay, and in terms of big data, that's the platform we were using. So a Spark with the CDH 541 and Hadoop. Okay, so I will not go into the details of this one, but this is, let's say in a nutshell, our continuous delivery pipeline and the way it was working. So the Jenkins master was pushing to Marathon, going to Mesos, and making sure that all the Docker images that were created in order to make sure that the system is working. Okay, so we just try to recreate a small scale of this real-life example. And so we create a test pass project. This is not the real project, so if any of our clients were in this room, they said, don't worry, it's not private code, it's just a sample that we did it for you. And we simulated as well a small ETL from Oracle to HDFS. Just because some of the data that they needed to process was on existing databases. Typically, the lookup tables may be the customer information that were on Oracle, and they needed to produce the output on HDFS. So we wanted, first of all the code structured using unit tests. So in a way that even every single unit of code was tested independently. But then, in order to make sure that the things were compatible with the deployment, we needed to make sure to create a real environment with CDH and to do a real life test. Okay, so that's the overall flow of the ETL. So the ETL is reading from Oracle, is instantiating a CDH cluster, and then is running this part job, processing some input data from Oracle and generating some output on the file system. And then we needed to make sure that even integration test was successful before merging the code. Okay, let's go to the demo. Still 3/5, so my phone is fine. So let's have a look first of all of the tools. So the first tool that we're going to use is Gerrit. So this is the GUI of Gerrit. Horrible. It's really not nice, but it's really powerful. Because first of all, it gives you an overall view of what are the open changes across all different repositories, and this is really good. In this case, I've got nothing. But just to give you some example of a real live code review system, so Gerrit review, for instance, this one is the one we use for developing Gerrit. So we develop Gerrit using Gerrit. Typically, in a real life project, we've got much more than that. And you've got plenty of changes. And this is good because it allows to have an overview of what's going on in the project. Yeah? And this is updated in real time. Yeah, there is someone that is pushing 3 minutes ago, just some changes. So typically is much more populated than this one. And on Gerrit, you can have an overview on all the repositories you've got by listing the repository. In our case, the repository we're going to use is this one, Spark ETL demo. So, and the repository has been just cloned locally. Maybe I will increase the font. Okay, just asking to the ones on the bottom, can you read the screen? Hello? The people in the bottom, can you read? Yeah, it's fine? Okay. So in this case, I just configured my repository, and I'm pointing to Gerrit. So Gerrit itself is not allowing just to define the code review, but it's acting as it was a Git server. And in reality, it is a Git server. That because it is a real implementation of the Git protocol and on the Git repository. So the jobs that I defined to test this situation, sorry, there we go, are 4. Why 4? So in this case, because the pipeline that I just built for this demo is a bit shorter than the one that we had. But just to showcase the concept and to give you the, just 1 second, just to authenticate it. Nice. That's the demo effect. 1 second. This is Jenkins. Okay. There we go. Go into the loop. Okay. I will not show you the pipeline view, but this is the typical pipeline view. So the jobs I've got are 4. 2 are for the development stage. They are called the unit test and the integration test, and they are linked one to the other. So whenever I make a change, unit test will be triggered, and if the unit tests are successful, they will trigger the integration test. But then, if the scoring part, so the diamond that you've seen at the bottom is positive, that will trigger automatically in Jenkins the ability to run a release candidate and deploy to the pre-production environment. So let's simulate a situation where a developer has a nice idea about a change. The change is working, but maybe it's breaking something in the integration test phase. And typically, what it could be breaking, maybe some negligible details, such as maybe an uppercase here, maybe some changes on the test data. This is something that typically developer doesn't spot because the developer is so focused on their code and the code is always tested in unit, in isolation, so they've got some predefined test data and the result, and maybe they don't care about a lot of the integration test and the final result. So in this case, I'm going to make a change that influences just the integration test phase. And then I'm doing my commit. There we go. Sorry, I need to add this one. Yeah, that's the change I've done. Let's commit it. It's very simple change for JUC 2015. There we go. So just one thing to notice. So in Gerrit, whenever I do a commit, Gerrit asks me to create a specific ID for my change. This is because when I go through the lifecycle, it may happen that my commit needs to be amended multiple times, right? Because maybe my change was done, but it's not good enough. I need to rework 3, 4 times, right? So in order to make sure that all the different commits, they're related to the same thing, I need a unique ID that is never going to change. And if I amend my commit 3 times, what do I get as Git ID? If I amend a single commit 3 times, do I get 3 times the same commit ID, or do I get 3 different commit IDs? 3 different commit IDs. And this is a problem, because I need to say, listen, those are not 3 different things. This is the same thing. I just reworked the same thing 3 times. And that's why Gerrit asked me to put this change ID. I don't have to do anything manually. Gerrit puts this hook automatically with a specific script that you need to execute. OK, now I'm ready. So if I do push origin master, this will go directly into the target branch. But if this change is not good enough, I'm going to break the build. So in order to tell Gerrit that this change needs to go for review, you need to specify, instead of master, you need to specify res for master. And this is a simple prefix that you put to the target branch that just tells Gerrit, hold on, I'm not really sure about the things I'm doing. Can you please do a code review about that? OK, when you push the change in this way, please, network, assist me. Yeah, still on? Yeah, gone. Yeah, fantastic. That was the most important part of the demo. Oh, anyway, so when this is finished, Gerrit comes back by saying, hold on, well done. I just created a specific change that as a code is 23. They give you a URL, and this URL is really nice because it can be shared by anyone just by copy and pasting into the web browser to ask other people to contribute to this change. Imagine that you want to tell, I don't know, maybe a data scientist or maybe someone in the business might say, can you have a look at what I've done? You just give the URL, they put in the web browser, it just works. And they've got a very nice view on what you've done. They see the commit message, they see the changes you've done, they see who you are, and they can see a lot of other stuff. So, and this is really good because just by saying push res for master, I don't have to create a feature branch, I don't have to create a pull request, I don't have to do all that ceremony. So you can just reuse the same way that you normally interact with Git. OK, so that's the first part. So I submitted my change. So the beauty of Gerrit is that allows to be integrated automatically with Jenkins. And as you can see, has automatically triggered the unit test. So even if my change is not on the target branch, I was able to ask Jenkins, can you tell me if this change is good or not? And if I drill down into this build, I will see that the build has been done. Just a few, OK, this is the UTC time. So it's not 7 p.m. today, but it is 7 p.m. in the UK. And you've got as well the reference to the Gerrit change that's triggered this one. So if you follow the hyperlink, you will go to the Gerrit change we have seen before. And on the Gerrit side as well, so if we go to this change at 23, sorry, not this one, this is Gerrit. This one, you will see that I've been already given automatically a first feedback that is called verified +1. And this has been given by JUC Jenkins build. So this is the automatic part of the workflow we have seen. OK, so the people may say, OK, Luca, but you're not showing me anything different what I'm doing today. Please explain why you're telling this, why it's different than a normal, let's say, continuous integration validation with Jenkins. So the difference is this one. If you don't use code review, and you just push the changes to your branch, you get the Jenkins validation, typically the developer, when he gets a +1 by saying the build is green, what do? They are happy, they go home, they go enjoy the countryside, they go having a drink with friends, and they don't care about anymore. They say, yeah, my change works, and they are happy. In reality, when the system gets complex, this is not true, because you're not happy when your unit test works, but you're happy when everything works. But the problem is, okay, how can I make the developer waiting for the final result, but without, let's say, losing their time? How can I enable the developer to continue working actively, but still providing a unique way to provide multiple feedback by saying, guys, you can't submit this one until you do something more. So as you can see, there are other two flags here. One is called code review. That means is necessary that not just something automatic such as Jenkins gives you a feedback, but even someone that physically look at your code by saying this makes sense or not. So a human person that goes there and say this is good. When I say human, could be even a kind of automated human. For instance, there are some guys that are called Black Duck. They do some automatic review. This could be another type of feedback you get. And there is one guy that built as well an integration with Sonar by saying you can get other review coming from Sonar and giving you this feedback. Okay, in the meantime, whilst I was talking, you know, Italians, they talk all the time, so apologies about that. Something happened. You see that small pop-up on the bottom right? Apologies for the pop-up, it's really small. In this bottom right, you don't notice. This is because the GUI really sucks. But this is a message that is telling you that something new happened, right? And this is because whilst I was talking, another step automatically was triggered. And as you can see, I got now a result on the integrated flag as well. It means that the developer, still using the same link, will get feedback not just on unit test, but even on all the other phases. Now I put verified and integrated. I could have put even a third step that could have been deployed to pre-production, because maybe it works in terms of unit test, maybe it doesn't break anything, but maybe it can be deployed because for whatever reason. Yeah? So the developer gets this type of feedback all the time. And the developer cannot merge this change until it gets positive feedback. So let's have a look at what happens. So when I go to the comments, I see as well what created this type of problems, right? I see that a build was successful, but another one was not. And if we look at the integration test, you see this one is red. So my change actually broke the integration test. Now, I know what it is, but let's have a look as well. If I go to the results of the build here, that was the related change. At the end of the day, there was a problem here, yeah? Because I was expected to have all home, camel case, and instead I had all uppercase because I just did it on purpose in this way. So in this case, the developer, what does it do? Typically, he goes and fixes the problem. So in this case, I may say, yeah, that was in this way. Problem fixed, just put something else here. Which was just this one, camel case, yeah. And then, the second time, I need to do minus amend, because the previous commit never made its way to the destination branch. So I need to make sure that this time is right, and after amend, I push it again. Again, as you can see, I didn't do any extra feature branch, I didn't do any extra commit, I didn't change the way I push. I kept on doing the same thing, I just amend the same commit. So it's quite easy for, oh, I forgot to stage my changes. There we go. And we're done. And this is going. So this one will automatically, so this will not create a different change, but this will just create a different patch set on the same change. So let's have a look what's going on here. Okay, I didn't go through yet. Just 1 second. Yep. It can push. Okay, now I should go through. So there we go. It has been done. And there we go. You will see that there is a second patch set. This is because I need to make sure not just to change my commits in order to fix them, but even to remember what was the first one, what was the second one, right? Because many companies, for traceability, they need as well to understand what was going on. Because when they see maybe 1 million extra, 1 million less, they need to understand exactly what was producing this outcome. And these will automatically do the same build that we have seen before. So this will trigger, again, another unit test. It was successful. So if we do a refresh here, there we go. We'll show that this one has been now verified, and we'll get the feedback on the integrated as well. So whilst the integrated is going, I wanted to show you some additional thing that we did on the integration test. So as we needed to make sure that we are running on a real cluster, we actually used, as I said, the Docker instances. And then we needed to tell to the Jenkins job that in order to work, you need to make sure that some Docker images are created. So we used the Docker integration with Jenkins. How many of you are using the Docker plugin with Jenkins, apart from us? Yeah, we are too. That's good. More people should use this one, because this is really great. It allows, instead of using existing slaves, and existing slaves will have the problem that they record the state. It means that your build is dependent on the previous build. This one allows you to create on the fly complete new machines. In this case, we created a new Oracle on the fly. We created a new CDH on the fly, and all happens in seconds. We start the containers, we create the containers, and then we execute our shells. And then at the end of the day, we shut them down. We used as well some variables in order to make sure that different people working concurrently, they were not competing on the same resources, so they were creating different containers. Okay, let's have a look if now the build is successful. It's still running, so we'll see that eventually. And this will provide the final feedback. Okay, so let's go to the second point. So now I've showcased as well how can I make a change and break things, but how can I get the feedback, get the people notified, and fix the problem. But then, when the things get more complex, you may have multiple people working on the same thing. You may have maybe one feature that is split across 3 developers, and 3 developers, they do 3 different commits at the same time. How can I make sure that, first of all, I get a unified view of what they do, and I make sure that all the changes, they are merged together? So let's go again to the same example, right? And let's simulate the different changes together. So imagine that I do again just a small change here just to break the build. There we go. And let's imagine this is the commit from the first developer. So first developer change, right? There we go. And I push it. But instead of doing the push as I was doing before, I'm adding an extra information to Gerrit. That is, I need to tell Gerrit that these different things that I'm doing, they are related to the same problem, right, that I want to solve. Imagine that I call this one topic 1. So what is topic 1? Topic 1 is a logical name that you can give. Could be your issue ID, could be whatever you want. That is just telling Gerrit that whatever I'm doing has to be grouped in a single way. When I do review, when I commit my changes, and when I submit my changes. So if we look at Gerrit, what happens is that when I see all my changes, I see as well that one of the change is not just a target branch, but it's even a topic name. That is topic 1. In the meantime, as I said, this one was verified, the one that we've seen before. So this time, code review, good. Shall we merge it? Good. Let's do it. So I'm doing code review +2. That is saying that this code is good to go. Then I can click submit. As you can see, the people, they don't have to do anything more from the command line. So there is not anymore the ceremony or creating branch, merging branch. Just push, and then when this verifies my conditions, I just submit, and that goes directly to the target branch. Okay, so I push my new change to my first topic. But imagine that now there is a second developer that needs to make another change as well to this one. And maybe the second developer make a change that doesn't break anything, just this one. Okay, let's stage this one. And let's call this one second developer change. Let's push it again to the same topic. So it means for Gerrit, we'll understand that there are different things going in parallel. Now they are on the same repo, but they could be on completely different repos. Imagine you've got 5 developers, they're working on the same type of feature, but they're working on 5 different repos. So when you tell Gerrit that those different changes, they're related to the same topic, they end up into the same topic label. So when I go and see all the changes here, you see that all belong to the same topic. And if I click on the topic, in this case, I've got just this one, so I don't see any filtering. But imagine if it got a lot of changes. When you click on the topic, it will just show you those 2 changes. As you can see, the first one has been reviewed, the second one not yet, right? Yeah, this doesn't have a feedback anymore because I need to wait for the build to complete. But then what happens is that this time, as those different changes that got a topic name, I will not be allowed to do the merge as I was doing before. Before, I reviewed each individual change, and I committed each individual ones. But imagine that the integration test needs everything. I definitely need to make sure that those things are going together, right? So let's wait just a second if this one is finishing. Yeah, it's running integration test phase. So if we look at this one, yeah, it's still running on this one. So let's leave this one running. When this one will be finished, I will show you as well then how can you get the different changes and merge them all together. Okay, I would like to show you as well another thing that was really useful for us. And we were saying, for instance, that our client needed absolute traceability of what produced what. So needed to be sure that whenever a new thing was rolled out to production, they could have, let's say, just gone back in time and see exactly who did what and when this change was validated by who. And this is really good. So we said, yeah, you can go to Gerrit. But the client said, listen, Gerrit maybe exists today, doesn't exist tomorrow. I want something that is going to be inside the code as well that gives me this kind of assurance. So what we implemented is one feature in Gerrit that is called the Git nodes. So the Git nodes are some additional piece of information that you can attach to a commit to provide some additional validation in terms of workflow. So in Git is really powerful because it allows you to put metadata to your commit and how much you want. In this case, Gerrit, whenever I do a change to a specific commit, I can tell, listen, I want to archive inside the commit all the verification that has been done. So when I do then git log --nodes equal review, let me just pull the latest changes. It was there. Yeah, I will show you. Basically, Gerrit gives me a feedback inside the Git itself on what was the review history of what I've done. So as you can see, I see that my code has been pushed. Let's go up. Okay, it was authored on the 2nd of September. In this case, this is a commit that I did this morning. As you can see, I was jet-lagged because I was awake at 5 a.m. Anyway, so I pushed this code this morning, and this code has been pushed on 5.06, but then has been, first of all, checked for unit test, and then integration test, and given code review +2. In this case, by 2 different people. One was the automated build, and the second was the author. I can see as well the reference to the URL while the review was taking place. I can see the project and the branch where this review was taking place. And then at the end of the day, who pushed that button, submit, so who authorized this change, and when the authorization was taking place. As you can see, these different things may happen at different times, in different time zones as well. So in this case, our client was distributed across 3 different sites. The main site was London, but there were people in Tel Aviv as well, and there were people in India. So it was quite common that maybe the change was done in India, but then was modified by someone in Tel Aviv and then reviewed by people in London. So you can see here that the change was being authored in California, but then submitted, let's say, in this case, by Gerrit, that is in the GMT time zone. So this is an extra additional piece of information that is really useful if your large client requires this type of compliance. In our case, definitely it was, because it was the changes that were driving some important piece of money. Okay, let's go back to my different changes. Okay, as you can see, one change was good, but the other was not. So this one was not good. And the first one is building, but the first one will get a positive feedback. Yeah. So what you need to do then on this side, so we got the first developer change was not good, the other was good, so let's fix it. So I will just go here. There we go. And let's see what was the problem. So the problem was, of course, the same piece of code that was changed here. There we go. There we go, this _1, and I can fix it. Done. Okay, fixed, and we can push it again. Okay, and these will go through the whole process. So as the build will take a little while, and before showing the submission of all, sorry, what I did is we were rejected. And on new changes, I forgot to do the commit minus susman. Yeah. Yep. Questions. Yeah. Okay. I just suggest to go for the questions and answers. In the meantime, okay. And in the background, we'll just fix this, so we'll see the final results.